Hi everyone, myself Dr. Lakshmi Prasad, working as a professor in the Department of Computer Science and Engineering, Hyderabad. In this video, I am going to discuss about graph terminologies, representation and its types. So the very first thing is that, what is a graph? So graph is nothing but a generalization of simple concept of sets or dots, links, edges and arcs. So the representation is that, the graph can be represented as G is equal to V of V comma E. So which consists of set of vertices, which should be denoted by V, and or I can able to represent it as V of G, and set of edges, what we call it as E, and it should be represented as E of G. So the graph should be a collection of vertices and edges which should be represented as set of V comma E, or I can able to represent it as vertex of G and then edges of graph G. So some other types, there are two types of edges, so directed edge and indirected edge. So directed edge is nothing but the ordered pair of vertices and should be represented as U comma V. So that should be the vertex and edge is starting from U and then from to E. And undirected edge, so unordered pair of vertices, what we call it as undirected edge, and should be represented as U comma V. And in this one, so here the edge is going to be represented simply without representing any kind of directions here. So whenever I'm going to represent an edge with a direction like this, so it should be called as a directed edge. And whenever I'm going to represent simply one vertex to the another vertex, then I can call it as an undirected edge. So what is the loop here? So loop is an edge whose endpoints are equal, that is an edge joining the vertex to itself is called a loop and should be represented as U comma U. And multiple edges means that, two or more edges joining the same pair of vertices is nothing but multiple edges. So whenever the vertex is there, right? So whenever there is an edge started and ending with the same vertex, so then should be called as a loop here, and whose endpoints are not equal in the case of loop. And multiple edges means that, whenever an edge is passing from one vertex to another vertex, two or more edges that is joining from the same pair of vertices, so that one what we called as a multiple edge. And graph types, so that means simple graphs. So the simple graph is a graph which does not contain any loops and multiple edges, and it should be defined as a consists non-empty set of vertices and edges set of distinct pair of vertices called as edges. And it should be represented as Z of V comma E, where E should be the set of vertices in the graph. So U, V, W, and then E is nothing but this edges, what is there in the graph, that is U, V, VW and then UW. And multi-graph means that, it is also a graph which consists of set of vertices V and then set of edges E, and a function from E is defined as U comma V, such that U comma V belongs to V and where U does not equal to V. So the edges E1 and E2 are called multiple or parallel edges here, and so it should be represented as same. So edge vertex set and then edge set. So whenever the graph is going to maintain the multiple edges in between them, so then I can able to call it as a multiple graph. And next one is a pseudograph. So pseudograph is nothing but consists of set of vertices V and set of edges, and there is a function from F from E to edges set, and the loop also going to have in this graph. Suppose if a graph is going to maintain both the multiple edges and the loops also going to be there, then I can able to call it as a pseudograph. So till now, three types of graph what I discussed. Simple graph. So the simple graph may not have multiple edges and then set of loops, whereas in multiple graphs the edges are going two or more edges are maintaining between the two pair of vertices. And the pseudograph is the thing where we can able to maintain them to multiple edges and then self-loop. So this kind of graph what we called as a pseudograph here. And directed graph means that, so it is a graph where the edges is going to maintain the directions here, and so it should be defined as G of V comma E, set of vertices and set of edges, and ordered pair of elements is going to maintain here. So that is nothing but a directed edges. And the graph is going to be represented as V comma E, so where E should be the vertex set and then X set here. So the graph, directed graph may not equal to undirected graph. So here the edges set here is that, so UV is there, and then VW, and then WU. So these are the edges set in this one. So whenever I am going to draw an undirected graph similarly, so the edges set may be different in this case. So the edges set may be UV and VU, and then UW or WU and VW. So this directed graph and undirected graph edge set may not be equal. So because of this directions here. The next one is the directed multigraph. So what is the directed multigraph here? So here it should be a graph, so it should be able to contain set of vertices and edges, and there is a function from E to vertex such that, so all the edges E1 and E2 should be the multiple edges. So because whenever the graph is going to maintain the multiple graph is going to maintain the direction, then I can easily say that there should be the directed multigraph. So in previous one, so in multigraph here I am not maintaining any kind of directions here, so that's why it should be called as a multigraph. So whenever the graph is going to maintain these directions, then I can able to call this one as the directed multigraph. So if you look at this different types of graphs, the comparison if I'm going to construct, so the simple graph may be undirected edges, or may also have directed one, but the simple graph does not allow multiple edges and then loops. In multi-graph, the edges should be undirected one only, but the multiple edges are going to be allowed in multiple graph, and the loops are not going to be allowed here. And then pseudograph, so where can I able to allow both the multiple edges and the loops. And directed graph, so in directed graph, so the edges, multiple edges are not allowed and then loops may be allowed. And directed multi-graph, so where you can able to allow multiple edges and then loops. Like this, we can able to make the comparison between the different types of graphs. So the simple graph is the graph where we can able to maintain only the simple edges, and multi-graph is going to be allow the multiple edges, and pseudograph is going to be allow both the multiple edges and the loops, and directed graph is going to maintain only the loops allowed, and then directed way multi-graph where can able to allow both the multiple edges and the loops. So when it comes to terminology of undirected graph here, so U and B are the adjacent. So whenever an edge is an incident with V and U and B, and U and B are called endpoints of UV. So how can I able to say that this U and B are adjacent? So whenever an edge exists between the two vertices, that should be incident between U as well as V, where U and B are at endpoints, and then I can able to say that they should be the adjacent vertices. And then degree of the vertex. So the degree of vertex is nothing but the number of edges incident on vertex is called the degrees of vertex. So suppose if I'm going to construct this vertex, so the number of edges that this vertex is maintaining is 2, that's the degree of vertex used 2, and this is also 1, and this one is 1. So the degree of u equal to 2 and degree of v equal to 1 and degree of w equal to. So similarly, next we are going to see about what should be the degree of v. So it should be the degree of the vertex whose degree is 1, what we call it as the pendant vertex, and whenever the degree of vertex whose degree is 0, so this degree of vertex k is 0, so this will what we call it as isolated vertex. Okay, so whenever I can able to say that the vertices v and u are adjacent here is that, so whenever the edge is going to be installed on both the edges on these two, what we call able to call as the adjacent vertices. And degree of vertex is nothing but the number of edges that are incident of the vertex is nothing but degree of the vertex. And pendant vertex means that degree of v should be 1 and isolated vertex is nothing but degree of k equal to 0. When it comes to the directed graph, so the two vertices are said to be adjacent whenever there is an existing edge between the two vertices in the directed form, and the degree of the directed graph is split into two types, what we call as a in degree, and the second one is out degree. So what is this in degree means that the number of edges from which u should be a terminal vertex, and in degree means the number of vertices and number of edges that are incident on the vertex is called as the in degree here, and number of edges that are leaving from the vertex what we call it as the out degree. So the number of edges from which u should be is a initial vertex here, and the total degree of this vertex v should be calculated is that, so degree of in degree plus out degree. So the in degree of this vertex is 1 plus 1, so totally 2. So the degree of vertex is 2. Similarly in this graph, so what should be this degree of u here? So in degree there is no incoming edge is there for u, so that's why the in degree is 0, and 2 edges are leaving from this vertex, so that should be 2. So the degree of vertex u is 2. And similarly, what should be the degree of vertex v? So there is one incident vertex, so in degree is 1, and one out vertex, one edge is leaving, so that's why it should be 1 plus 1, 2 here. And what should be the degree of w? So there is 2 incoming edges, so 2 and more outgoing edges are there from w, so that's what we call as 0. So the degree is 2. So when it comes to the theorems of undirected graph, so according to handshaking theorem, so the number of 2e should be called as summation of degree of vertex v. So what are the other kind or other special cases of this simple graph here? So here the Kn, what we call as a complete graph, so it should be a simple graph that contains exactly one edge between the pair of distinct vertices. So K1 means that it is a complete graph which does not have, which is going to have only one vertex, and K3 means that, so this is a complete graph which is going to maintain the 3 vertices. So that means there is exists an edge between one vertex to another vertex that should be completely connected. And K4 means that, so it is a complete graph which is going to maintain 4 vertices, and there exists an edge between from one vertex to the all remaining 3 vertices. So complete graph is one of the special cases of simple graph. And next one is the cyclic. So what is the cyclic here? So whenever the edge is going to be form a closed loop, so then there exists a cycle in the graph. So the cycle is going to be formed whenever the number of vertices should be greater than or equal to 3, and the cycle is going to be represented in the form of C3 and then C4. That means there exists a cycle in the vertices of order 3, and there exists a cycle of number of vertices 4. So next we are going to see about wheels. So wheels is nothing but it should be obtained from the vertex to Cn and then connecting all the vertices to the vertex by new edges. So this wheels are going to be represented as W3 and then W4. So what should be W3 here means, so there exists a wheel from number of vertices plus 1, so 4 here. 4 vertices are going to be there in order to exist a wheel, and in order to exist and 5, so I can able to get 4 plus 1. So the wheels can be obtained from additional vertex to Cn and by connecting all the vertices to the new vertex by new edges here. N cubes, so N cubes is nothing but it should be represented as Q of n, and where the vertices are going to be represented by 2n bit strings of length, and the two vertices are adjacent if and only if the bit strings that they are represent that should be different from exactly 1 bit positions. So if I'm going to consider two vertices here that should be represented zeros and 1, so if I'm going to consider 4 means I can able to represent so 0 0 0 1 1 0 1 1. So the n cubes is going to be represented in the form of 2n bit strings of length n. So where the two vertices are going to be adjacent if and only if the bit strings they represent differ by exactly 1 bit positions, and these n cubes are represented by q1 and then q2. And next one is bipartite graph. So in bipartite graph, so here the graph in simple graph, the vertices are going to be partitioned into two disjoint sets v1 and v2, such that every edge in the graph is going to be connect the vertex v1 and then vertex v2. So if I'm going to consider a vertex v, so the vertex is going to have v1 v2 up to so on v6. So what I am going to say in bipartite graph, so this vertex set is going to be partitioned into two disjoint sets and going to be represent there is edge from one vertex, from vertex v1 to vertex v2 like this. So whenever I'm going to represent this, then I can able to say this graph should be a bipartite graph. So mainly in this bipartite graph, the vertex is going to be split into two disjoint sets. And this one where can able to maintain two different kind of vertices, and there exists a mapping between the one vertex to the other vertex. Next one is that complete bipartite graph. So in this complete bipartite graph, so it should be represented as KMN. So which is a graph that has a vertex set partitioned into two subsets, and there is an edge between the two vertices if and only if the one vertex is the first subset and another vertex is the second subset. So that means whenever I'm going to consider three bipartite graph, that means so there exists a map between the two and the two vertices among the three vertices. Similarly, if I'm going to represent K33 means, so the mapping that is going to exist between vertex set of three vertices and a vertex set of under three vertices. So like this, the mapping is going to be done between the complete bipartite graph. And what is a subgraph here? So the subgraph is nothing but it should be the some part of the graph. So if I'm going to have a graph like this, so some part of the graph if I'm going to consider, then I can able to call this one as the subgraph and should be represented as H1. And similarly, this UV I'm going to consider, this is also some part of the graph, so this should be also a subgraph here. Similarly, if I'm going to have, so G1 is one graph and G2 is another graph. So if I'm going to match both the graphs, and then G1 and G2 is going to be clubbed into one graph that should be called as a simple graph. And next one, representation. So how the graphs are going to be represented. So in this one, so we can able to represent the graph in different ways. So first one is that incidence, so that should be matrix representation, and adjacency list representation. So the most useful when information about the edges is more desirable than information about the vertices. So that's why incidence matrix is going to be considered. And adjacency matrix or adjacency list is another most useful when information about the vertices is going to be more desirable than the information about the edges. So whenever I'm going to be maintain the more information about the edges than the vertices, then I have to consider this incident vertex. And whenever the information about the vertices is more desirable than the edges, then I can able to have adjacency list. So consider a graph G which should be an undirected graph. Suppose that we are going to have V1 to Vn and edges we are going to have E1 to Em. And how can I able to represent this? So normally this incidence matrix is going to be mapped along the vertices and edges, and this matrix is going to be filled with values either 0 or 1. So whenever there exists an edge from EH which is going to be incident on V at x Vi, so otherwise it should be 0. So the multiple edges can also be shown in this incident matrix, and the loops can also be shown it as entry 1 in the matrix. So let us consider a graph here. So the incident matrix is going to be mapped along the vertices and edges. So what are the vertices? We are going to have U, V, W. So all these will be the vertices, and E1, E2, E3 should be the edges here. So how can I able to mark these zeros and ones? So whenever there is a vertex V, so I'm going to have edge E1 and E3, so that's why it should be 1 and then 0. So for there is no edge is reflecting on V, so that's why it should be 0. Similarly, if I'm going to consider U, so the edges what are reflecting in this one is E1 and E2, so that's why I'm going to make this 2 as 1 and E3 as 0. And next one, so for vertex W, so the E2 and E3 are reflecting, so that's why it should be 1, and E2 should E1 should be 0. So like this, the incident matrix is going to be represented here. So if there is an edge unbound matrix, so how the adjacency matrix is going to be represented. So for undirected graph, so the matrix is going to be filled with zeros and ones, and then for directed graph also it should be zeros and ones whenever there exists an edge between them. So in adjacency matrix, so it should be chosen in order of the vertices, and so whenever the relatively free edges of the graph in the graph, so the adjacency matrix is post matrix, and the directed multiple graph should be represented by using AIC. So let us consider a graph here. So in this one, how this adjacency matrix is represented. So this adjacency matrix is going to be represented among the vertices. So whenever there is a vertex from V1, one vertex to another vertex, so whenever the edge is there, so I can able to fill with 1, otherwise it should be 0. So in this one, I have an edge from U to V, so I have mapped 1, and then V to W, so it should be 1 here. And for V to V there is no edge, so that's why it should be self-loop, so it should be 0. So similarly, if I'm going to consider U, so what are the edges that are, what are the vertices that are connected V and then W? So that's why V and W are connected, so it should be 0. Sorry, it should be 1. And similarly, if I'm going to consider W, so what are the edges that are connected U, V? So that's why it should be. So in case of this directed graph, so same adjacency matrix is going to be considered, but based on the directed edges are going to fill with zeros and ones. So if I'm going to consider a vertex V, U, so it should be, there is a directed edge, so that's why it should be 1. And similarly, there is no other edges pointing from V, so that's why remaining all should be 0. Similarly, if I'm going to consider U, so there is an edge that is coming from U to W, so that's why it should be 1. So remaining all should be zeros. Similarly, if I'm going to consider W, one edge is going to be connected to the vertex V, so that's why it should be 1, so remaining all should be 0. And next one is that adjacency list. So how this one is going to be presented. So in a graph, if I'm going to consider, so what are the vertices that are connected to the vertex node is going to be considered. So in this graph, so what are the nodes that are connected is U, V, W. So that's the nodes. And what are the vertices that are connected to the node U is that V and W. So V and W I'm going to write here. And then for vertex V, so what are the edges that are connected, vertices that are connected, W and then U. And for this one, it should be 0, U and then. So like this, we are going to be represent the graph in the form of adjacency list. So here in this one, so how to consider U, V, W. So what are the adjacency list is nothing but what are the adjacent vertices that are connected to the vertex is going to be have this adjacency list. So these are some of the different representations of this graph. So normally this representation of the graph will be in 3 ways we can able to represent it. So first one is that incident matrix. So incident matrix is the one so which is going to have more information about the edges. So it should be the incident matrix is going to be considered. And adjacency matrix or adjacency list is there. So normally this adjacency matrix is going to be considered when I'm going to have a graph among these vertices to vertices. And adjacency list means what are the vertices that are connected to the vertex is going to consider in adjacency list. So in instant matrix, sometimes you can have negative edges also. So let us consider another graph what I'm going to be considered. So if I'm going to have a graph like this, so and the edges what we have E1, E2, E3, E4, E5, E6 and E7. So A, B, C, D, E. So these are the list of vertices and E1, E2, E3, E4, E5 and E6. E7. This should be the set of edges here. So for A I'm going to have E1 and then E2. So that's why it should be 1. So remaining all should be 0. And for B, so E1, E3 and E4. E1, E3 and E3, so remaining all should be 0. So similarly I'm going to consider C here. So E2, E3, E5 and E6. So remaining all should be 0. So like this I'm going to construct the instance matrix. When it comes to adjacency matrix here, so if I'm going to have the graph like this, so if I'm going to have the graph like this, so I can able to consider U, V, W, X, Y, Z, and similarly here also U, V, X, Y, Z. So like this I'm going to consider, and according to that I can able to fill the values with either zeros and ones. So whereas in case of directed one, so whenever there exists an edge, then that one is going to be considered. In adjacency list, so what is the other way I can able to show it? So the node U is there. So in adjacency list, so what are the vertices that are connected? For U it should be V and W. So this should be the linked list representation. And for V, U and then W. So this is the other way of representing that. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.